Thanks, Stefan. Yeah, as Stefan mentioned, we'll be talking on linked data and the web evolving into a global data space. So, as for the classic web, as we know it, it builds a single global document space built on a small set of simple standards: HTML as a document format, HTTP URLs as globally unique identifiers, and HTTP as a retrieval mechanism to access these documents, and HTML hyperlinks to connect documents. Moving on to the Web 2.0, this is still not a single global data space. Web APIs popped up, but the shortcomings of the Web 2.0 and Web APIs are that Web APIs have proprietary interfaces, which means mashups built on Web APIs are based on a fixed set of data sources, and there's no hyperlinks between data items inside of different Web APIs. So Web APIs basically slice the web into walled gardens, which you separately have to access. What linked data provides you is it extends the web with a single global data space. So by using RDF to publish structured information, structured data on the web, and by setting links between those data items in different data sources, it enables a global data space. Tim Berners-Lee in 2006 published the linked data principles, a set of best practices to publish linked data on the web in accordance with the general architecture of the web, the classic web. So first of all, rule number 1, use your eyes to identify things. Second, use HTTP URIs to make people able to look up, to access those things. And when someone looks up a URI, provide useful information in a machine-readable way, meaning in RDF. And last of all, include RDF statements that link to other data sources that are relevant and similar to the entity or to the thing you're describing. So RDF, being the representation language of linked data, RDF provides you with means to describe entities on the web of data. RDF allows you to describe, in this case, the entity Chris, which is of type fourth person. You can describe not only properties Chris owns, like he has a name, Chris Bietze, but also object relations to other entities on the web of data. Chris is based near Berlin. And as data items on the web of data are dereferenceable and are represented by HTTP URIs, DBpedia Berlin can be further resolved over the web of data and resolved or retrieved for more information. So we can get the population and the subject of Berlin. Berlin is a city in Germany and has a certain population. And this allows for further traversing this web of data by getting other cities that are in Germany, located in Germany. So the properties of the web of data, it builds a globally distributed data space built on a simple set of standards, RDF as the data language, representation language, URIs as entity identifiers, and HTTP as a retrieval mechanism. Entities on the web of data are connected by links, which creates a global data graph that spans every data source, or could span every data source that is out there. It enables also discovery of new, and in this case, unlimited discovery of new data sources. Linked data provides for data coexistence. Everyone can publish their data on the web of data. Everyone can publish it in their own view on the data, and everybody can use their own vocabularies or schemata to publish linked data. In 2007, shortly after Tim Berners-Lee published the linked data principles, the W3C Linking Open Data project started, which is a grassroots community effort to publish available open data as linked data on the web of data and interlink those data sets with existing other data sources on the web of data. You've seen this already, but in 2007 we started off with 12 data sets and over 500 million RDF triples on the web of data, connected by 120,000 RDF links between those data sources. This further evolved to, in late 2007, 28 data sets, and as the years passed by, we came up by now with 295 data sets with over 31 billion RDF triples in those data sets and over 500 million RDF links connecting these data sources. As you can see in the picture, the web of data represents different domains in different colors in this way. So to the right you can see the green large subdomain is the libraries and publications domain as one of the biggest domains or subsets on the web of data. There's also the government domain to the left and the life science domain, which is pink in the south of this diagram. There's also geographical data on the web of data, media data, as well as user-generated content, and in the middle you can see cross-domain data sets spanning different domains. Just a short overview of the sizes of each of these domains. As you can see, the publications and library domains with 87 data sets is the largest domain on the web of data, and also concerning the links, with 30% of the links is a highly interconnected graph already. You can find further statistics on the websites provided here. As one of the first and still main data sets on the web of data is Wikipedia, which is a joint project with the goal to extract structured information from Wikipedia and publish it under the same and open license on the web of data, and also to interlink this data set with other data sets on the web of data. So what is there to extract on Wikipedia? First of all, you have articles in different languages. You can extract the label, the title for each of these articles and entities of the real world. Furthermore, we extract abstracts in all these languages that are available to display in any of your applications you want to build upon these. You can extract images, and what you might know to the right, there's always some small table, the info box, which contains further information, structured information on the resource itself, like for Berlin, the population, the mayor's name, the elevation, and etc. And also for different resources, there's different other information to be extracted. As for places, there's geocoordinates. For persons, there's PNDs, etc. So Wikipedia then publishes this extracted information as RDF, which is, as you can see, publishing labels in different languages, geocoordinates, etc. And also, since it is a graph and a connected graph, it also contains statements of things that link to the resource you just extracted. In this case, SoundCloud, a company, is located in Berlin. You can access the Wikipedia data via the dumps available on the website, via normal web interface as well, via the Sparkle endpoint to query the data, and also via the linked data interface to dereference the URIs and traverse further into the web of data. The Wikipedia dataset contains information on more than 3.6 million things, amongst them 416,000 persons, 169,000 organizations, places, nearly half a billion of them, and 24,000 books. And overall, the whole Wikipedia datasets consist of more than 1 billion RDF triples, meaning facts that were extracted from Wikipedia, with 2.7 million links to images for these things, and 6 million links to external web pages, and also roughly 6 million links to other linked data sets already out there. Last year we opened up not only the Wikipedia ontology for collaborative editing on a wiki, but also the mappings for Wikipedia tables and info boxes to this ontology, which by now has grown to a community of 7 languages being mapped, 7 Wikipedia languages being mapped to the Wikipedia ontology, which allows for a significant increase of the extracted data's quality, because each domain and each language has its own experts. So Wikipedia itself, as it is a cross-domain dataset, as Wikipedia is one, builds a hub on the linked data web. It is not only an interlinking hub, but also a source for further information for data integration. Wikipedia can be used, or the Wikipedia dataset can be used in different applications to enhance and visualize your data. In this case, you see Wikipedia Mobile, a mobile travel guide, which displays geocoded Wikipedia information on a map, and also integrates different other data sources. Wikipedia can also enhance the Wikipedia search. You can do faceted search on Wikipedia data. In this case, you can search for persons that were born in Stuttgart, are somehow related to Berlin, and were furthermore born between 1905 and 1945. You can make up any query you can think of. Skyscrapers in China that are higher than 24 levels, whatever, 200 levels, etc. And Wikipedia is a great source for building text annotation tools. In this case, Wikipedia Spotlight, which can be used to annotate any English text with Wikipedia or Wikipedia identifiers, which, since Wikipedia offers disambiguation, works quite well. And also is not restricted to only person, places, and organization, as usually named entity recognition tools are. So, coming to the overall uptake of linked data, as we've seen in the morning, there's a huge uptake in the governmental sector. The UK and US government publishing thousands of data sets with billions of RDF tuples on the web of data. The EU itself is pushing linked data with not only Europeana, but also other linked data projects that should move to also publishing EU datasets as linked data on the web. There's a WCC government linked data working group as well. Inside of the libraries community, there's a vast amount of institutions publishing linked data by now. You've seen this over the days. There's the Library of Congress, which started publishing linked data, started publishing their subject headings as linked data. The German National Library has joined in, the Swedish, the Hungarian, and the British National Library, and of course the Europeana project publishes a large amount of data on the web of data. As for activities, there's the WCC Library Linked Data Incubator Group, which helps standardizing schemata, and which is a good pointer to head to if you plan publishing linked data for libraries on the web of data. There's also the OKFN working group on bibliographic data, which works on addressing institutions to open up bibliographic data. Yeah, and the overall goal for the libraries community is to integrate library catalogs on a global scale and interconnect all these overlapping resources between different repositories by topic, by historical period, etc. One of the first adapters of linked data was the media industry, which publishes mainly RDF XML or websites enriched with RDFA on the web of data to drive traffic from search engines onto their websites. So one of the first of them was the BBC to publish linked data. The New York Times, The Guardian, Newsweek joined in. And yeah, to connect the classic, or to be able to connect the classic web with the web of data, you have to annotate, you can annotate web documents with linked data URIs, which allows you to connect your classical documents with these data sources to display information, to display web of data information into in your websites and to enhance your websites. And also it improves, if you interconnect your web documents with the web of data, it improves search by using the structured data as background knowledge. Also, as shown before, there can be, text annotation tools can be built on the web of data. For example, OpenCalais, a service offered by Thomson and Reuters, is text annotation for news. Semanta is annotating blog posts, and the Wikipedia Spotlight can be used for any entity types and texts. There's a variety of applications that can build on linked data. There's not only linked data browsers and search engines, but there's also mashups you can build on linked data. So as an example for a browser, this is Marbles. It allows you to look up a UI. In this case, the UI for Tim Berners-Lee's fourth profile. And it shows you aggregated data from the web of data. It shows you with these colored dots that many sources claim that Tim Berners-Lee is a person, that he's working for WCC, etc. As for linked data search engines, these allow you to search for keywords on the web of data and return all the facts that contain and are related to that keyword. In this case, Chris Bietze, and you can find for every fact, you can find the provenance information to the right. Where did that fact actually come from? You can also filter those facts and sources. The BBC Wildlife Finder is a nice example of a linked data application. It is a website on endangered species. It enhances, or the website is enhanced with the Wikipedia data, not only images to Wikipedia images, not only links to Wikipedia images, but also structured data. And it furthermore publishes its own information also as linked data on the web. So, as a data integration service or as a data consumer, linked data lowers the integration costs. So, the overall data integration effort is for linked data split between three parties: the data publisher, third parties, and the data consumer itself. The data publisher publishing its data as RDF on the web. He can set already links to other data sets, and he can also reuse terms from other schemata, or at least publish schema level mappings. And third parties can enhance this data by also setting links to other data sources, or publish further schema level mappings on the web of data. And the data consumer, integrating all these data, can use record linkage and schema matching techniques to further integrate and deduplicate the available data. So how do you publish linked data? So first of all, make your data available as RDF via HTTP. Set RDF links pointing to other data sources. It doesn't have to be for equivalent entities on a web of data, but it could be any relation based near the author of a book, whatever. Make your data self-descriptive, which means make your schema also available on the web of data and dereferenceable. And if you can, reuse common vocabularies and schemata. So if you're thinking of publishing linked data, there's also this 5-star plan by Tim Berners-Lee, published in 2010, which guides you through how to open up your data. Like, first, open up your data, make it available on the web and an open license. Further, go to linked data and interlink this data. So, what does linked data provide us with? It provides a standardized access interface to data. It also allows the development of a variety of tools to integrate, enhance, and view the data that is out there. The web of data is growing rapidly, as you've seen. There's a huge amount of communities out there working in different domains on publishing data as linked data. And also web search is evolving into query answering, using structured data as background knowledge, as Google, Yahoo, and Bing already do it, will increase the usability of search engines. Thanks.